Hello everyone, and welcome to this virtual conference. It's truly an honor to have the opportunity to present my work to such a distinguished audience. Before starting this presentation, allow me to present myself. My name is Anass bin ABDELOUAHAB, first year as a PhD student in the National School of Applied Science in Kenitra. My presentation is entitled Artificial Intelligence and Industry 4.0 Trends and Comprehensive Review and Case Study Analysis in the Moroccan Context. This work has been made with Adham, CHAIBI, Samia, HAMAN, Zineb, Bentassil, and Abdelmajid, ELOUADI, and Aniss MOUMEN in the Engineering Science Laboratory. In this presentation, we will start with an introduction. We will move to the objective, then research methodology, a result synthesis, and then conclusion. Artificial intelligence is a driving force in Industry 4.0 revolution manufacturing process globally. Moroccan strategy embrace of Industry 4.0 principal position key sector like automotive, aerospace, textile, and agro industry for enhanced productivity and competitiveness through AI integration. Overcoming challenge in infrastructure and workforce readiness is critical for Morocco to fully harness AI transformative potential and maximize Industry 4.0 benefits in its industrial evolution. The objective of this presentation is to present a comprehensive study on the relationship between AI and Industry 4.0 using a SLR systematic literature review approach complemented by a case study focused on the Moroccan context. For the history of evolution industry, in the first step was the introduction of water and steam power mechanization production and leading to the rise of factory, and the second is the between 19th and the 20th century adoption of electricity and assembly line boosting mass production and standardization. In the Industry 3.0, the integration of computer and automation advancing manufacturing process with digital technology. Industry 4.0, the present is the fusion of the cyber-physical system, IoT, AI, and big data, enabling smart factory, predictive maintenance, and data-driven decision-making for optimized production. What is AI? AI is mimic human intelligence in machine to perform tasks such as learning, reasoning, problem-solving, perception, and language understanding. From AI, we found machine learning. Machine learning is a subset of AI, focused on developing algorithms that enable machines to learn from data and improve over time without explicit programming. We have also deep learning is a subset of machine learning, uses neural network with multiple layers to learn representation of data at different levels of abstraction, excelling in tasks like image recognition, natural language processing, and decision making. The methodology followed in our paper to increase the immersion of search result primary study were selected based on keyword in the search function of a search engine. The search string as follow: artificial intelligence and between two brackets Industry 4.0. After collecting many references using Zotero and after deleting duplicating to achieve in the third step an acceptable level of accuracy. In applying the selection criteria, we reviewed the abstract of the paper, found to dispose of the ones that are out of our scope. The number of the selected article for analysis was reduced to 114 papers. Those references will be analyzed using in vivo and VOS viewer. For the interview methodology, the first part was to identify the problem and objective of the study, specify the objective of the qualitative study, make a list of questions to discuss with the person concerned, write a participant selection questionnaire for the individual interview, develop an interview guide for facilitating in the interview, conduct individual meeting, analyze, record data during meeting with in vivo, present the synthesis and draw guideline for the study. Then in the second step, for the processing data or data processing, first data collection, transcription, definition of units of analysis, coding or classification, analysis grid, quantification, and graphic representation. Our result and synthesis in the figure 1. After the database join, from Scopes, Springer and Science Direct. The identification. This step allows us to identify all potential study within the scope of our topic from different sources. Screening. During this step, the identified study are examined based on the title, abstract, and keyword to determine if they meet the inclusion criteria. Studies that do not meet the criteria are discarded, while studies that meet the criteria are retained for further analysis. Third step is the eligibility. The eligibility stage consists of a more in-depth evaluation of the full text of the study, of the quality of the study by checking that they made the inclusion and exclusion criteria defined beforehand for the systematic review, and complete and detailed studies that are not sufficiently detailed and that not meet the criteria are excluded, and the eligible study are included for analysis. At the right, we have the production of the number of reference per year. From 2040, we have the increase of this number of paper until now. For the word cloud, we can see that represent the most recurring word in the corpus. The word intelligence, industry in the middle, artificial maintenance and predictive are the top of the occurrence. In the second and the third level, the word found are manufacturing, challenge, application, data, learning. Those figures show the classification of each question per article. As we will see in the figure 8, the fourth question and the classification. First question is what are the area and domain where AI used? Second question, what are the challenges of applying artificial intelligence in Industry 4.0? Third question, which artificial intelligence techniques are typically used as part of industry? And the last question, what are the benefits of applying artificial intelligence in the Industry 4.0? To answer the first question, at the right we have the figure 9. We found that after the industry, maintenance and manufacturing, as well as the cyber-physical system, are among the top 4 on the area concerned with AI, and this due to the importance of this area in Industry 4.0 on maintenance also, and more precisely predictive maintenance with AI tools to save machine and the cost of reparation. For the figure 10, it's about to answer the third question, which artificial intelligence technique are typically used, and we can see at the top of this distribution by reference and by method, we see the AI in general, machine learning, deep learning, machine learning and deep learning, and etc. for different algorithms. The analysis of article from Scopes to viewer revealed 3 main research clusters. The first focus on AI and in industry, exploring applications like automation and predictive maintenance. The second cluster emphasizes machine learning and the Internet of Things, highlighting advanced algorithm and interconnected system. The third cluster, at right in yellow, addresses sustainable development, digitalization, waste management, and circular economy initiative. These findings showcase the intersection of technology, sustainability, and industry in Morocco, offering insights for policymakers and researchers. In this table, we have the sensitivity from different or high cited reference with the objective, method, field of research, and some results. For Lee, number 3, they try to use the AI algorithm for predictive maintenance in monitoring critical machine tool system that is needed for a maintenance strategy that decrease downtime cost and increase machine availability. The same for number 4, focused their study on addressing industrial maintenance issues, which are vital components driving Industry 4.0 advancement. To present the second file in manufacturing, we introduced the work of Massaro, number 5. In this work, we found that they used AI in production optimization, and similarly for number 6. They worked with AI to choose the optimal material for manufacturing. Finally, to discuss the cyber-physical system file, we can see the work of Mr. Radanliev and the other authors. This paper introduced the AI designed for CPS. In the same case, we see the work of Ashraf and all other authors. The use of machine and deep learning artificial neural network, least square support vector machine with the power plant optimization with artificial intelligence to adjust operate parameters. As a result, the generative powers experience average increase of 1.74 and 1.8 and 1 at 50, 75 and 100 generation capacity respectively within the power plant. The second table for the 5 authors, the use of productive performance and faulty detection in CPS draw the utilization of machine learning technique, specifically random forest and deep learning methods such as time series analysis combined LSTM. Their approach achieved an accuracy rate of 80% over the lifespan of the product. For the third question, for the challenge, we found the challenge of applying AI in Industry 4.0. We found in this paper, Meyer others, 10, the lack of guideline for implementing machine learning in the manufacturing industry economically. On the other hand, with paper of Lee, it's 11, they work on the concept of the long training time and difficulty in optimizing and retraining the NN model for full diagnostic in a large-scale rotationally machine. Also, the author Turkan and Mason present the challenge of lack of overview and understanding of predictive quality research in manufacturing. At the end, Wang et al. 13, business innovation based on AI and blockchain technology, the use of AI in manufacturing, the result more than 97% on the ratio of demand prediction, business development, product quality, behavior, customer analysis, and customer satisfaction. At the end, for the interview result and synthesis, we found a similar result as the research paper. The must answer was for the technique the deep learning, machine learning, computer vision, NLP, natural language processing, speech and image recognition, smart robotic, and predictive analysis. In the area field, we found also maintenance, manufacturing at the top, and we found another field like supply chain, automotive, cybersecurity, energy, quality, forecast, and transportation. To conclude our work, AI in Industry 4.0 presents significant advantage in optimizing Industry 4.0 processes such as maintenance, manufacturing, and cyber-physical system, enhancing efficiency and accuracy. The challenge and opportunity, despite challenge and like data scarcity and algorithm limitation, AI offer promising opportunity for improving Industry 4.0 process globally. For the Moroccan context, in Morocco, while there are intersecting global trends in AI adoption, unique challenges such as infrastructure, competency gaps, cost application, and security concern need tailored approach and a collaboration for effective AI implementation and leveraging its benefits in the industrial context. Thank you for your attention.